Alright, I'm all the way through the case. So I had to retouch a little bit the cathode connector of the LED. I need to solder new wires and or connector to the print board. There you go. So yeah, I made it back home, and I know you guys had to wait quite a while for me to put up a new video on my channel, but you know, I'll make a confession. I needed some me time, okay, and I needed to sort of switch off my mind a bit and think about other stuff, or not think at all, you know, just relax and look around and enjoy life in general. Anyway, I'm back home, and as was expected, or rather as I thought that would happen, I am being immediately confronted with something very unpleasant. Now, I don't know if you people know this, but where I live, which by the way is in Belgium, cars need to get a yearly inspection to see whether they are still roadworthy, yeah, whether they can still be insured and driven on a daily basis on our roads. Yeah, I think the British call it an MOT. I'm not sure how they call this in Canada or in the US or even in another country. But anyway, in Belgium, once a car reaches 4 years of age, it has to undergo a yearly mechanical technical inspection. And whenever something is discovered which makes your car legally not roadworthy, they punch a card, and the things that are punched on the card or the paper are the points you need to have your car checked for. And obviously, once your car gets even one punch, it is suddenly not roadworthy anymore. Yeah, you can't drive it legally. You're technically uninsured if you drive a car like this, and until of course you get your car fixed and then get it through another MOT to prove that it is indeed fixed. Now, those MOTs, or those technical inspections, aren't for free. Yeah. In fact, every inspection costs about 50 euros, and that is without the expenses for having your car repaired. So this year I went to the inspection, to have my car, you know, technically inspected. So the car is 10 years old, and for the second time, I should say, it's getting an MOT. They discovered another problem with it, and the problem is this. This is the right mirror, driver mirror, or I should say car mirror, turn indicator. Okay, so basically what this is just a piece of plastic and with a few orange LEDs here, yeah, because then a direction indicator in Europe at least has to be orange, not red, and the orange LEDs shine in that direction along this plastic light guide you see here, yeah, which reflects the orange light outward. Okay, so this is nothing but a transparent piece of plastic which reflects the orange light, which starts here. Yeah, and there's a little prism here which directs the light beam all the way around this plastic guide here, light guide. So yes, my car got disqualified to be driven because one turn indicator didn't work. The law here says that whatever is on or in the car, at least if it's visible, yeah, if it's visible, it has to work. So if you install lights and or other ancillaries to your car, they need to be roadworthy and they need to function correctly. And obviously, well, you know, this is visible. This is on the outside of the right wing mirror, outside mirror, and it's a light, so it should function, yeah, legally, and it doesn't. So yeah, that ticked me off a bit. I mean, the previous MOT disqualification was last year, and that was a shock absorber, which was bad. I mean, yeah, I get it. A shock absorber should function correctly. So I had that repaired, which cost me, by the way, quite a nice sum of money. So now this year is just a turn indicator. So this, which is broken and which got my car disqualified. And believe it or not, so I went to a local garage, you know, workshop, where they repair the brand of my car. You know, my car is a Peugeot car, and it's a Peugeot garage, a Peugeot workshop. And I told them what the problem was, that my car got disqualified for a broken indicator light. And they said, yeah, no problem, we can fix it for you. And I said, oh, great, because I got a grace period of 2 weeks to show up again at the MOT. And if I don't, then I'll have to get the car all the way back through MOT, you know, the whole MOT, not just the light, but indicator, but the whole car again, which would again cost me $50. Yeah, no problem, they told me, we can fix it, just give us a moment to look up the part. And so I waited 10 minutes, half an hour. After almost an hour they came back to me and they said, well, yeah, we can get the part, but it's a little bit expensive. And I said, okay, what do you mean by expensive? A little bit, you know? And they said, well, you know, without taxes, it'll be $180. You know, and I was kind of silent for a few seconds. And then I said, what? $180 without taxes for a piece of plastic with just a few LEDs in it? you know, just a light strip, a line of light, and you're charging me 180 euros, you know, without the costs of the installation, mind you, so for which they charge 75 euros per hour. Okay. So I said, no, no, no. Okay, so a closer look at the indicator tells me that the translucent, or I should say transparent plastic you see right now has been more than likely ultrasonically welded to the black piece of plastic, or perhaps even glued, but I don't see obvious traces of glue. So I suspect the part has been welded. Okay, so I basically decided against making a cut in the transparent plastic, you know, on this side here, to extract the print board. For a couple of reasons mainly. First of all, this translucent or transparent side is basically, even if you don't see it, it's on the outside of the indicator light, and thus it's exposed to the weather. And if I'm going to make a cut in this, yeah, it won't be that resistant anymore to weather influences, you know, rain, ice, snow, you name it. So I decided against cutting through the transparent side for that. And secondly, of course, I also did not want to structurally damage the outside shell of the indicator light, because that could be something they would disqualify the car for again. Alright, I clamped down the indicator to the table outside with a clamp, and I used some soft padding to put underneath it, such that I wouldn't, hopefully, not damage the transparent plastic cover, right? So the idea is that I would use a metal saw like this. Okay, so let me zoom out a little. So the idea is I would use a metal saw like this, yeah, and saw manually two slits in the plastic cover at the back with the saw, and thus free the little print board inside. I discovered a flaw in my plan. Namely, you remember that I said that there are two metal pins hidden inside this plastic entry here, which was where the original connector would be, well, connected, right? And if I'm going to saw right here all the way down, I'm going to saw through those two pins. Well, I guess, you know, I could try to saw around it, but nah. You know, I'm going to sacrifice those two pins, because I'm going to mount another type of connector anyway. And there you go. I managed to extract the little print board. You see here. Okay. Nothing special really. There's a marking at the back which says, let me see, W494-94V-0. I think this is more like a model number, you know, and there's a small QR code there. So I'll see if my smartphone can read that QR code. Maybe it'll tell us something intelligible, right? So that's the QR code. Yeah, like I feared, the saw cut through the contact pins and they are bent. One of them is broken. But I mean, that's not a big deal. I can repair that. What I do see now that I have the print board is that at least one of the LEDs, specifically this one, the lower one, looks a bit burnt. Okay, I'm going to give you a closer look at the module that we extracted, or that I extracted from the indicator light, you know. And on the screen, the first thing you see is the top LED. Okay, so here's a closer look at the PCB on my or under my microscope. Right now what you see in the screen is the top LED, and that one still looks functional to me. And then if I slide the PCB up a little, you see the middle LED, and that one really looks clean and healthy. Yeah, so the middle LED, I can say with a high degree of confidence, is still functional. And then I slide up the PCB a bit, and there you have the lower LED, you know, the lower of the three LEDs. And I think you can tell for yourselves that that LED is well, is end of life. Yeah, I can try to give you a close-up of it. Let's see. There you go. So that's a close-up of the LED, and yeah, you can tell for yourselves that this LED is end of life, right? Is broken. Now, if you notice in the lower right corner, there is a code for the LED. Now, I'm not sure whether the code reads as 330W or 330E, you know. I need to look it up. Okay, so as far as I can tell, if you read it left to right, the code says 330W, yeah, and the little line under it would indicate that indeed that's how to read it. But yeah, you could probably interpret it as a capital letter E as well. Okay, so then let's show you the power transistor or power regulator. I don't know what it is exactly, but there you go. So it's a BCP 56. Again, don't look at me yet. I haven't done any looking up yet. You know, I have done no research as yet what these parts are, okay? I'm just showing you what is built onto the PCB. Then there's a small resistor, which, if I'm not mistaken, is 12 ohms. Unless, of course, it's 1200 ohms, but I think it's 12 ohms. And then when we move the PCB on, you see a 2200 ohms resistor, I think, or could be 220 ohms. Again, I have to look it up, I'm not sure. And then there are two transistors, I think. Yeah. Again, I don't know if they are PNPs or NPNs, but I'll look it up, right? So the left one is a JST62. The right one is an A7W62. Right, and then to end up, I'll show you the contacts that unfortunately I had to cut through to extract the little PCB. They are damaged, but that's okay. If need be, I can replace them. And underneath them, I think that's either a capacitor or a 0 ohm fuse. I'm not sure yet, so it could be either. Right, and then to end up, let me show you the other side of the PCB, the back side. And there you go. That is the code printed at the back of the PCB. Okay. So I would guess the left upper corner is the logo of the maker, WL or WI, surrounded by a circle. And the code below it would probably be a part number, W494V-0. And to end up showing you around on the PCB, let me show you the QR code printed at the back of it. There you go. There you go. You can scan it as much as you like. It'll give you a very long number, but as far as I can tell is meaningless, unless of course it gives you possibly a production date and an inventory number, maybe either used by Peugeot or the maker of the PCB. But either way, to me at least, the number itself is meaningless. Unless, of course, you have a suggestion, and then I would say write down the suggestion in the comments below the video, right? So there you go. That concludes for now the tour of the PCB. So what I'm going to do next is I'm going to unsolder the bad LED you see right now in the image, okay, and have a closer look at it to try to figure out what type of LED I might need for the repair. Mind you, in the lower right corner of the LED, you see the corner has been dimpled. You know, there's like a little triangle at the lower right corner of the LED. As far as I can tell, that is designates the position of the cathode of the LED. Okay. Obviously, the other contact would then be the anode, I would think. But since this LED, this specific model of LED, has 4 contacts, I need to figure out first what the meaning of those contacts are. So I was still, curious about the PCB, and my curiosity pushed me to find a solution to try out at least the active components of the PCB to see whether they are still functioning normally, and whether I could find a way to make the PCB as a whole still function somewhat as the original, while the fully working PCB would have. So what I did was I calculated a resistor value which is pretty close, the same sort of load as a normally functioning LED, and I came to a value of 12 ohms, which I looked up in my stash of parts, and I found a 16th watt 12 ohm resistor, which you see right here. It's a tiny little resistor. Yeah. Okay. Which I mounted exactly where the old LED was mounted, right? Now it turns out that there are 4 contacts, but the one contact in this corner here is the cathode, and the other 3 contacts are anodes. In other words, the cathode is common to both elements if you use a double element LED. Okay. Either way, I connected up the resistor between one of the anodes and the cathode to simulate a load similar to an LED, and then I hooked it up to the power supply. So, and this is what I got. No, I didn't get smoke or a big bang. I got this instead. Two very bright amber colored LEDs. So, which confirms my suspicion that the only broken quote-unquote LED was the one at the bottom, right? So the 2 top ones are still good. Okay, so you could say this is the cheap solution to get it to work again, right? If you replace the broken LED by a 12 ohm resistor. Now, ideally, of course, you would use a 1 watt resistor and not a 16th of a watt resistor, okay? Because, I mean, in pulse mode like this, the resistor is probably okay. It's a metal film resistor. It'll resist burning up, yeah? But if you'd have the lighting go on continuously, then yeah, that would not be advisable, okay? Because a resistor will overheat, seriously overheat. Unless, of course, you use, like I said, a 1 watt resistor instead of a 16th of a watt. But in pulse mode, so in in a mode like this, you know, the resistor will hold up perfectly. Yeah. Now I have to say, although this is subjective, the middle LED, to me at least, seems a little bit less bright than the top one, you know. So the light is a bit uneven from both. But I mean, for somebody who wouldn't know that that is the case, they wouldn't even notice it. You know, I notice it because I'm very much interested to see how it functions, right? So yeah, um, that would be the cheap way to repair one of these modules. Um, but in my opinion, of course, it's still better to have all three LEDs function, since, you know, legally speaking, the indicator lights need to have a certain wattage, you know, so a certain brightness to be legally acceptable on the road. Okay, so yeah, you know, if you want a quick and dirty solution, this is it. Alright, I opted for the middle of the road solution, namely replacing the middle LED as well. Because the original LED looked a little bit roasted, and therefore I suspected would probably fail as well soon. Now, of course, due to my rather as yet still poor skills at SMD soldering, I ended up roasting the other two LEDs as well, you know. But at least now it works, and I have to say though that the replacement LEDs are, well, I would say slightly more bright than the original ones. Have a look for yourself. The LED, excuse me, the LED on the left is still an original one. The LEDs on the right are the two new ones. So judge for yourself, right? Now I have to say they look slightly reddish, although I don't doubt that they are what the packaging says, namely amber colored LEDs, but they are a heck of a lot brighter than the original LED, you know. So yeah, they are very, very bright. Yeah. And I would say yes, they are amber colored, but it's a little bit more reddish, I think, and it's way more intense than the original. Yeah. Okay, so judge for yourselves. In my opinion, yes, the replacement is a success, but boy oh boy, did it ask a lot of work. I still need quite a bit more practice in SMD soldering, that's for sure. I have to say though, although these LEDs were sold to me as amber colored, they look awfully reddish to me, or at the very least very, very deep orange, you know. So I'm not sure these are amber colored LEDs. I mean, compared to the top one, which is truly amber colored, which was the original one, the lower two are, well, not exactly amber colored, you know, but they are incredibly bright. I mean, now I'm filming them at 6 volts, 6 volts 6, right? You see over there? So at 6 volts 6 they are incredibly bright. So you can imagine at 12 volts they are like superlatively bright, right? So yeah, not bad where brightness is concerned. Color though, I'm not very pleased by the color. Okay, and there you go. I soldered 2 wires, a red and a black one for the positive and the negative, to the print board, and to finish it off I encased the wires in a protective nylon cover, you know, which is very flexible and protects the wiring from physical damage. You know, it's not obviously watertight, but it gives the wires just that little bit more oomph to survive a very hostile environment in a car, right? So yeah, and I deliberately made the wire long, about 45 centimeters long, yeah, so I would say 20 inches somewhere about, yeah, that way I have enough leeway to install the whole wire, and it's well finished and protected against mechanical harm. Alright, there you go. Maybe a close-up. Okay. I capped both ends off with a little bit of heat shrink. Okay, just to make it neater. Alright, so here is the mirror of the car in which I need to place back the indicator light, and you can see here's the slit where it was removed, right? So the first thing I need to do now is remove the mirror itself and the top housing, so to access the interior of the mirror. I swung out the mirror completely to the outside position, right? So in order to access behind the mirror, and I'm using a plastic shoehorn, yeah, to undo the mirror, because well, you shouldn't use metal or glass implements to do this, because you might damage something, right? So I need to first of all unmount the mirror itself. So let's just do that. There you go. The mirror is unmounted. Now there are still 2 little wires attached to the mirror, and that's for the defrosting of the mirror. So I need to pull that loose to completely remove the mirror. There you go. So now the mirror has been completely removed. We can move on opening the case or the back of the mirror. So just in case you're interested to know, so this is the back of the mirror itself. Now you saw me disconnect the defrosting connector here. Normally speaking, this is, as far as I know, not polarized, but still it's probably best to remember how the mirror should be mounted. Okay, so there you go. Alright, and then the interior of the mirror looks like this. Alright, and inside the mirror's case, here and here, there are clips that I need to undo to remove the outer shell of the mirror, so this shell here. Okay, so here are the wires that, well, the mechanic botched the repair, you know. Normally there should be a little connector here then which would connect up with the indicator light, but for some reason he cut off the connector and left the power cables for the indicator light floating like this with just a little bit of tape around the ends. So what I need to do now is go get my multimeter and establish which cable goes to which, so which one is plus and which one is ground or negative. Alright, I've got the indicator light with me, so now let's disconnect the multimeter and let's see if the indicator light will work instead, right? So let me connect up the thing, and there you go. I know there's a lot of sunlight for the moment, but yeah, I think you should see the indicator light blinking, don't you? So yeah, we know the thing works, so now we can move on to the next step, which is mounting back the indicator light, I mean the repaired one, which I'm holding right now. I'm feeling a bit like I'm in a movie right now, you know, where the main actor keeps wondering, which wire should I cut now? The green one? The yellow one? Or maybe the red one? You know? And yeah, but in my case, of course, there won't be any explosion, at least. I hope not. But I can tell you one thing, doing this outside, you know, next to a busy road, is really not very comfortable. Okay, I need both my hands to do this, and I can't keep an eye on you guys while I'm doing this. So I'll bring you back once I'm done soldering. Alright, I'm done soldering. All I need to do now is put some heat shrink around the contacts to insulate it, you know, in order not to have them make some erroneous contact with other wires and stuff. So let's slide the heat shrink over the repaired connectors. Now, again, like I said, this is certainly not my preferred method to repair broken contacts, okay. I would much rather have had a good connector that I could use to replace, you know. But obviously the mechanic who did the work, quote unquote, well, botched up his job, and well, I'm stuck with the broken pieces. Alright, I slid back the indicator light into its position, and you actually slide it back like this, okay? You come from the inside of the car, you slide, I don't know if you guys can see this, but you slide this part here into the slot on the side of the mirror, like this, and then you lower the whole assembly into its place, like that. Alright, so you need a Torx screwdriver, one like this, okay, and you need two screws like these, or like this, yeah. But apparently I seem to have misplaced one of my screws, so I'll only be able to show you me screwing one down, not two, because there are two screws you need to tighten inside the mechanism. So I'll give you a view of it in a moment, so hang on. Obviously you don't need to use a ton of force, you know, just screw the screw until it snugly fits, and there you go. So technically I'm good now, even with only one screw. But yeah, I'm not pleased with this, but I mean, when I find a replacement screw, I'll open it up later on, once I'm done with this. Either way, I just wanted to show you how to mount the whole thing back. Now, inside the shell, the outer shell of the mirror, you would find two clips like this, alright? Like this here. So technically there should be an identical clip here, but the tech who worked on my mirror broke off the top of it. But I mean, that's okay. I can still lock the shell in place, but it's not neat the way he did it. So anyway, to unmount the shell, you need to gently push these tabs to the inside while you pull or push out the shell, yeah. So you gently push these tabs towards the inside, but gently, not like what the tech did here. Yeah, he probably used excessive force. So yeah, once everything is mounted and you've tucked away the cables out of the way like this. Yeah, there's lots of traffic here, I can't help that. So, okay, so the cable is tucked away like this. Okay. So then you place the cap of the mirror on top of it, like this, and you should be able to slide it back into place. So like this. There you go. All done. Alright, so there you go. Yeah. Keep in mind it's a sunny day, so you obviously can't see the light very well, but it is blinking, as you can tell for yourself. So this is repaired. So I can finally, I hope, get my MOT now. So what I need to do now is mount back the mirror, and once we've done that, we're done. Okay, remember I said there's the defrosting of the mirror, and you know, it's best, even though it probably doesn't matter, to place the connector back the way it was, which I'm doing now. Yeah, and then you should place the mirror back in place and gently, and I mean really gently, you know, press it back into place on the hole. And you should definitely hear a click, right, to make sure that the mirror is back in place. And there you go. The mirror is fixed. Yep. All done. Alright, so there is the mirror. All I need to do is position it back to its original position. So let's do that. It's an electric mirror, obviously. So let's see, a bit like this, a bit like that. There you go. Yeah, that will do. So let's activate the blinker. Yep, it works. So we're done with this job. Thanks for watching, and I'll hope to see you all soon back on my channel for the next video. Bye bye.